Hi all. So we'll start with the session now. We'll do some questions from week one. This is a solve with us session where we'll be doing some questions from week one, and afterwards we can take up the doubts if there are any more left. We already had a doubt session. There are no other doubts left. So I'll just share my screen. I hope my screen's visible.
Yes, ma'am.
Okay.
Yeah. आपल्या स्त्रीकडे एकोणीसशे 86 ते आतापर्यंत आपण केलेल्या
Yeah, so we'll start with the first question. Before I solve it here, I I would like you all to give it a try, and then we'll solve it here. Drop your answers in the chat box. Okay, so we'll do it now in the class. Uh, the first, you have to check whether the given numbers are rational or irrational, or in simple words, which one are the rational ones. So first is 2 to the power 1 by 3. So it's the these powers of 2 are irrational in nature. So they're irrational because you can't actually write them as root 2 is irrational, and any further parts of, so it's 2 to the power 1 by 2, 2 to the power 1 by 2, 2 to the power 1 by 3, and so on, in every power basically where you have something here other than 1. So in the denominator, this just means this thing, right? So anything other than 1 here in the denominator gives you an irrational number. So the first one is an irrational number. So A is incorrect. Then moving on to the B part, you have root 8 plus root 2 and root 8 minus root 2. This gives you 8 root 8 square minus root 2 square. So it's basically 8 minus 2, 6. So this is rational. And C part is 4.87 and it basically ends. That's what matters. So this, because this ends somewhere, you can write it as 4, 8, 7, so on, 2 by 2, 3, and then 10 to the power 6. So this is a rational number because you can write it in P by Q form. Basically, your definition of rational numbers is you can write it in terms of P by Q where Q is not 0. So this is a rational number. Then root 2 by root 3 is not a rational number. It's this is irrational. Root 2 is irrational and root 3 is also irrational, and they don't give you a number which ends after the decimals. It won't end when you write it in decimal representations. Or in other words, you can try doing it in this way. If you're getting into the proof of why this is not a rational number, and if you write it as a rational number, you'll get this thing or this thing. And there isn't a rational number that gives you u square gives you 2 by 3. So this is an irrational number. Then you have root 8 minus root 2 and root 2 minus 1. So either you can try to rationalize this thing, uh, rationalize the denominator, or you can just simply write it as root 2 minus root 2. This numerator we have rewritten as this, and then root 2 minus 1. So this will be this will give you this thing. It gives you just 2. So this is a rational number. This option is correct. Then we have minus root 48 by root 27. This you can write as, you can try writing these things as 2 into, will be left with 24, then 2 again. So it's 12 and then 2, 6, and then 3 and 2. Then here you can write it as 3 into 3 into 3, which leaves you with 4, root 3, and 3 root 3. This gives you 4 by 3. So this is a rational number too. I hope this question is clear to everyone.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Then we'll move on to the second one. This is a very small, short question. Just give it a try. Just drop your answers in the chat box. Okay, so we'll solve it here now. So you've been asked to find the cardinality of M, and you're supposed to remove the set C. So this is your M set, and if you remove, this is M. So you just have to find the cardinality where you remove this part. This is C, this is M. That's what M minus C means. So you have to find this one, the cardinality of this thing. So you don't even have to consider these 70, 50 things. You can just add 10 and 40 because that's what we're looking for. We just have to remove this part. This part we have to remove. It's a pretty simple question. Is this one clear?
Yes, ma'am.
So we move on to the next one. Give this one a try. Okay, so that's enough time. I hope the ones you all have tried it and you've gotten the answers. We'll try it here now. So you have been given these three sets, and this set is M union C is this entire thing, and then intersection with S is this thing. This is the set whose cardinality you need to find. And so you can just add up these things. Here you have 40, then you have 50, and then you have 60. So it will give you 150. Give the third one a try. Okay, so let's just find out the sets first. R1 is the connection. So your S set is given to be natural numbers from 0 to 10. And then R1 is the collection here of XY tuple where X and Y follow this relation. Y is equals to 2X. So this should be, you'll put a 0 in place of X, you'll get 0. Then as Y, you'll get 0. So 0, 0, then 1, 2, then 2, 4, then 3, 6, 4, 8, and 5. As R2, you will get XY such that XY follow this relation Y is equals to X square. So if you put X 0, you will get Y equals 0. Then 1, 1, then 2, 4, and then 3, 9. The set. And if you take the union of these two, so you just club these two sets together and then subtract the one that are common in R2. So this gives you,
Ma'am, A is natural number. How can you include 0? 0 is whole number.
so in the set here, we include 0 in the set of natural numbers. For this course, you include 0 in the set of natural numbers.
Okay, ma'am.
Oh. Then 1, 2 is there, 2, 4, 3, 6, 4, 8, 5, 10. And from here, you include 1, 1, 2, 4 is already included, and 3, 9. And then you subtract this set, so you remove this one, this one, this one, and this one. So you will be left with these elements 1, 2, 3, and 4. So if you do R1 union R2 and then remove the set R2, the cardinality will be 4. Because you're going to remove the underlined ones and then the circled ones will be left in this set. R1 union R2 minus R2. Is this fine?
Yes, ma'am.
Okay, so we'll move on to the next question. This is the next question. I'm writing the other things to check for the reflexiveness and transitivity too. Check for reflexivity and transitivity. Okay, so the question is A and B are said to be related if they are living in the same city. So let's just say first you check for reflexivity. So for reflexivity, you need this pair to be in the relation. Let's just say this is your relation. So you want A to be in the relation, and you know the same. If A lives in a city, then that's A lives in the same city, right? If A lives in a particular city, then A will also be in that city. So A pair is in R. So it is reflexive. Next up, you have symmetry. So if A and B live in the same city, this would mean that B and A also, let's say A and B are two people. So if they live in the same city, then BA also, changing the order doesn't matter here. They'll also be in the same city. So it's symmetric too. And then last you have transitivity. So if AB live in the same city, AB are two people, they live in the same city, that means this pair belongs to the relation. And BC also live in the same city. Let's just say there's a city T A, B live in city T, B and C live in city T. So A, C also live in city T. So A, C belong to this relation. That means it's transitive too. Which would mean that
But
this is an
how?
equivalence relation.
But how it will be transitive? Say A comma B lives in city T and B comma C lives in city Y. Then A comma C is not the same city. It will
No,
not be
B
transitive.
cannot live in two cities, no?
Oh, yes.
So this is an equivalence relation because it is all three of them, transitive, reflexive, and symmetric. So it's an equivalence relation. Is this question
Please,
clear to everyone?
please repeat the reflexive part.
See, reflexivity means that you'd need A pair to be here. And when would A pair be here? Let's say you have A and A lives in city T. So you just have to check that A and A will be related if they are living in the same city. So if A is a person, then A and A live in the same city, right? Because it's the same person.
Oh, I get it.
Is this question clear to everyone? If there's a, if in case there is a doubt, just unmute yourself and ask because I'm not actively checking the chats. Give this question a try. Next one, fifth one. And drop your answers in the chat box. Also check for onto-ness in this question. Check for surjectivity too. So you have been given a question, a function fn as this one. So if you try to find some of the values, you can't possibly find all of them. So f at 0 will be 0. Then f at 1 will be square root of 2. It's 1 plus 1. So this will be square root of 2. Then f at 2 will be square root of 2 again. So you don't even have to go further to check on to 1-1-ness to check the 1-1-ness of this function. This function is not injective. Because f1 and f2 in this set give the same value. They're both mapped to root 2. So this is not a 1-1 function. Then coming to onto-ness. So your function is, it depends on the codomain. So your codomain is given to be real numbers. So the notation looks a bit different. It should have been like this. So if you will put a number here, let's just, if you want to check if this function is onto or not, one way to do it is, there are other ways too. One way is you take the function which you're not sure, it depends on the number itself. So if it's odd, then it's this, or otherwise it's this. So let's just take both of them, test both of these, and let's just take a random number C belonging to real numbers. So if C is any number, you would, if this is onto, then for any arbitrary C, arbitrary means for any random real number, you will find an n such that this function, such that fn will be C. So for onto, for any C belonging to R, any random C belonging to R, any arbitrary C belonging to R, there would exist a natural number n such that Fn will be equal to C. Right? That's what onto means. So let's just try to find this n for any random C. So we'll equate this to C. This is your function, right? This is Fn. So we'll substitute root square. What we're doing here is we're trying to find the value of n such that Fn is C, where C could be any number, any real number. So n plus 1 will be C square from here. And this will give you n is equals to C square minus 1. Now, if you will take C to be equal to, let's just say I take C to be equal to half. Because I can take any real number. Let me just take half. If I'll take C equals to half, half belongs to real number. Then there does not exist any n such that Fn is equals to half. Why? Because if you'll put half here, half square will be 1 by 4 minus 1. And this should have been the n such that Fn is equals to C. But this is not a natural number. Is this thing clear to everyone?
Yes, ma'am.
Ma'am, what does odd and even means here?
Odd and even is the usual odd and even. Odd means 1, 3, 5, 7, these numbers. And then 0, 2, 4,
Yes,
these
ma'am.
numbers are even
Ma'am,
ones.
but what does they mean at the place of the terms including n, like n plus 1 or root n?
What it means is, this is how you define the function. So the function is, the domain is a natural number, right? So this says that if you have an even number, then the function's value will be square root of n. So if you have 2, the function's value at 2 will be square root of 2. If you have 4, it will be square root of 4. And if you have an odd number here instead, then you will have square root of n plus 1. That means square root of 1 plus 1. If you have 3, you will have square root of 3 plus 1. This
So
is
ma'am,
what it means.
so ma'am, it needs to be a perfect square, huh?
No, it doesn't have to be. Root 2 is not, 2 is not a perfect square. Right? This doesn't have a square. It doesn't have to be a perfect square. Is this clear?
Yes, ma'am. Yes, ma'am.
Okay. So we've only checked for, you can
Ma'am,
also check for the second part. Yes.
Ma'am, if the domain was all real numbers, then it would be onto, right?
Then you would have to check. If, yeah, then it would be onto because
Again, n will be a real
then you'll
number.
have C
so it
square.
will-
It will be a real number then. You'll always get a real number here. Yeah, then
Okay,
it
ma'am.
would be an onto function. So you'd also have to check for this one. We have only checked for this branch where we say that we were not able to find an n. That is, we were not able to find an odd integer such that odd natural number such that square root of n plus 1 is equals to half. Right? That's what we said. We're not able to find an odd number such that this is half for an odd natural number. Similarly, you'll have to check for the even ones. This is this you do the same way. there is no natural number whose square root is half. Because if you do it, you will get this thing, 1 by root 2. And this is not a natural number. Right? Sorry, 1 by 4. And 1 by 4 is not a natural number. So that's the same case here. Is this part clear to everyone?
No, ma'am. Once again, explain it, ma'am.
Okay. See, what you have to do is you've been given this function where you have square root of n plus 1, where you've understood the function, right? How does it work?
Yes, yes. Yes, yes, yes.
This was odd here. Odd, and even when n is even, you take square root of n. That's how your function works. This function. So to check if it's onto or not, what you do is we first do it for any arbitrary number because we're not sure which real number will it not work for. So we try it for any random number and we try to find n such that fn is equals to c. So if for every real number, you're able to find a natural number such that fn is equals to c, that means this is an onto function. Otherwise, it's not an onto function, right? If you're
Okay.
able to find even one c such that there is no natural number, so if there is a c for which there is no natural number whose image is c, that means this is not an onto function, right? This is
Yes.
the set of natural numbers and you have a c here. So if there is no n here such that it is mapped to c, that means it's not an onto function.
Okay.
So we just have to find that one c. So what we do is, your fn is either it's square root of n plus 1 or square root of n depending on the number. So let's try for
Okay.
both of these. Let's just equate this thing to c and equate this thing to c. Why we don't take the number directly here, we're not taking half here directly because we don't know for what value of c will you not find an n, right? So we're first
Okay.
trying to see how it looks like. So we try to find n in terms of c, you get c square minus 1 from here and you get n is equals to c square. Now this is what it looks like. So if you need to find a natural number such that fn is equals to c, an odd natural number such that fn is equals to c looks like this, c square minus 1. And an even natural number such that its image is c looks like this, right? So if you'll take the
Okay.
c, now if you'll take c equals to 1, no, there could be a problem because 1 minus 1 is going to be 0. Then in that case, this is going to work. That means you can't randomly choose c here. You have to carefully choose c. Because if you take c to be 1, you'll get c, you'll put c here, you'll get 1 minus 1 equals 0. And 0 is a natural number.
Okay.
So that would mean f0 is equals to 1. So you can't choose 1 here. That's why we've done this thing. So choose c equals to half. You can choose anything else too. You could also choose 1 by 3. You could also choose 2 by 3. That's fine too. So we've taken the simpler one, 1 by 2. So if you do 1 by 2 here, 1 by 2 square here would give you 1 by 4 minus 1. And here it will give you 1 by 4. Now neither 1 by 4 minus 1 nor 1 by 4 is a natural number. That means you will not be able to find a natural number whose image is half, right, under this function. Is it clear?
Okay, ma'am.
Yes, ma'am.
Yes, ma'am. And we move on to the next question. If there's still a doubt in this one, I can repeat it again. That's fine.
Yes, ma'am. Please, ma'am. Repeat this one.
Which one? Which particular part are you not able to understand?
Ma'am, the root part, root n plus 1 equals to c. Ma'am, what if we change the term to something else like n square or something like that?
This term, are you
Yes,
talking
ma'am.
about this term?
Yes, ma'am. Yes,
See,
ma'am.
the function's already given to you. This is the function. So to find if a function is onto or not, what you do is you take any c from the codomain. This CD is codomain. You take any c from the codomain and try to find x such that fx is equals to c. If you're able to find an x such that fx is equals to c for every c in the codomain, that means it's an onto function. Now your function is given to be either square root of n plus 1 or square root of n. So we are trying to, for every c, we are trying to find an n such that either square root of n plus 1 or square root of n is equals to c. That's why we have done this thing. Is it all right?
Can you show us the question one time?
This is the question. Is this part clear now?
Yes, ma'am.
Does anyone still have a part in the doubt in this part? In simple words, we're just trying to find x such that fx is equals to c. But if you have a c here, then obviously x will be in terms of c, right? So we find x or n in terms of c. That's it.
Ma'am, where do they say n is a natural number in the question? The function?
Says here, no? This is n only. This is a set of natural numbers. I know the notation is not correct, but it's n.
Okay, ma'am.
So, ma'am, would the answer be no?
Yeah, it's not an onto function. It's not a one-one function either.
All right,
Not
ma'am.
one-one, not onto. Can
And
we
ma'am,
move on to the next question?
And ma'am, what can be the conditions where it can be defined as it is a 1-1 or onto function?
Conditions. So you're asking when can this some altercate, like if some changes are made to this
Yes,
function, then it will be one-one or onto. Okay.
yes, ma'am. Yes.
One-one, it's a little difficult. Then you'll have to change the entire function, right? Because you have the problem is f0 is 0, then f1 and f2 have same values, f3 and f4 have same values, and every consecutive pair of even and odd numbers, actually odd and even have the same values. So it cannot be 1-1. You'll have to change the entire function for this function to be 1-1. So 1-1 it can't be, but slight changes can be made to make it an onto function, like we just discussed. If you one very easy thing to do is you can just take the 0 here, then root 2 here, then root 3 you don't have to take, then 4 here. So you can take the square root of, in the codomain, you can choose to be the square root of x such that x is an even integer or even natural number. So if you'll take an even natural number, you will take the codomain to be this, then you will have this function to be an onto function. Because you've made the codomain equal to the range. This is the range of this function, and you've made it equal to the range. Then it will be an onto function. Is it fine?
Ma'am, I've got the onto part. Can you please explain the 1-1 part again?
Okay. This function we've only tried to find the values till 2, because till 2, you do it till 2, and then you can see that f1 and f2 are giving the same value. So 1-1 means, in diagram form, it looks like this. If you have these dots are the elements in set in the domain, and in the codomain, these dots are the elements here. So 1-1, if it looks like this, in simple words, if you have two elements mapped to the same element, then it's not a 1-1 function, right? So you have 1 and 2 mapped to the same. This is 1, this is 2, and they're both mapped to root 2. That's the problem. So because 1 and 2, 1 gives you 1 plus 1, it's an odd number. So you will put 1 here, you will get square root of 2. 2 is an even number, you'll put 2 here, you'll get square root of 2. So both 1 and 2 are mapped to the same number, square root of 2. That's why it's not an onto function.
Yes, ma'am.
1-1 function. Can we move on to the next question now?
Ma'am,
Yes.
if we just take the codomain to be just natural numbers, it wouldn't even in that case it would not be onto, right? We should make it
No.
even natural numbers, right?
Yeah, you'll have to narrow it down. This is the see for it to be onto, the simple condition is codomain should be equal to the range. So this is the range. Natural numbers is not the range for this function.
Okay, ma'am. Thank you.
Okay. And if you will take, you can't actually take natural numbers here because square root of 2 is image of 2, but it's not a natural number. So that function won't be defined then. So you can't take natural numbers here.
Ma'am, can you please repeat that? I didn't get it. The square root of 2 thing.
See, if you want to take n here, if you will take this thing, that's what you were saying, right? Then the function is not
Yes, ma'am.
defined because square root of 2 is the image of 2, right? F2 is square root of 2. But square root of 2
Oh,
is
yes,
not
ma'am.
in the set of natural numbers. This function won't be
Then
defined.
okay. Even in that case, it would not be
Yeah.
onto. Okay.
So you can't actually talk about onto because it's not a function. Then it
Okay.
won't be a function. Okay. Can we move on to the next question now? Just try this question. Wait, I'll just fix this thing. Just try this one, sixth one, and drop the answers in the chat box.
Ma'am,
Yes.
your voice is not coming.
Okay, so do you have a doubt or was this the only thing you wanted to say? Is it clear now? Okay, so we'll start with the sixth one. And just 1 second. I'm audible, right?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So this is your function, and you have to find the domain of this function. So for this function, domain just means that your function has to be well defined. Or in this case, you can just say that it's defined, right? So while checking here, you will just have to check one thing, that this is the denominator is not 0. That's the only thing that's going to cause trouble. So if your denominator is 0, then it will be problematic. And then there is a square root here. So you have to take care of two things. One is the square root and the other one is the denominator. This part you have to take care of, and then this part you have to take care of, because they can both create troubles. So let's just come to the denominator first. You would want x minus 5 to be not 0, right? Because if you have a 0 in denominator, then this thing is not defined. So first thing is your x should not be 5. This is the first thing that should not be in your domain. Then second, we'll come to the square root. So you would want your square root of x plus 3 to be defined. You want x such that square root of x plus 3 is defined. For that, you would need x plus 3 to be greater than 0, or greater than equal to 0. So subtracting 3 sides from 3 from both sides of the inequality, you will get this thing. So you would want x to be greater than equals to minus 3. Is this, are both these parts clear? This is your second condition, and your first condition is this. So on the domain, for your x to be in the domain of this function, you would need two things. Firstly, your x should not be 5, and secondly, your x should be greater than equal to minus 3. Other than that, you don't have any conditions here, right? But you need to find, so your domain actually is, we're talking about the domain for now, x such that x is greater than minus 3. Obviously, x is a real number, so x belonging to real numbers. Such that x is greater than minus 3 and x is not equals to 5. You'll have to mention that x is not greater than 5, not equal to 5, because 5 is greater than minus 3. Otherwise, you could just drop this condition. This is your domain, but you have to find the set of integers, right? That's in the domain. So you have to intersect it with set of integers. So here you will get, so this is minus 3 included till infinity, this thing. Let me just write it here. This set is the interval minus 3 to infinity minus the number 5. And you have to take the intersection of this set with set of integers. Is this much clear?
Yes, ma'am.
Okay. And then you just have to take integers from here. So it's like this. 0, minus 3. And it goes till infinity. So now that you just have to take the integers, you can just remove these parts that are not integers. So it will be this one, then minus 2, then minus 1. So it is, you can write this set as set of z belonging to set of integers such that z is greater than minus 3. So in set form, you can write it in this manner. And here on the line, you can see it's all the integers greater than minus 3. All integers greater than minus 3, excluding 5. So it's this option, B option. Is this clear to everyone?
Yes, ma'am.
Is there a doubt?
Ma'am, I didn't quite get the interval part properly.
The interval one, right? This says you're clear till this part. You don't, do you have a doubt till this part? Till this part, everyone's clear, right?
Yes, ma'am. Yes.
Okay.
Ma'am, there's too much background noise.
It's not on my wait. Okay, so you have -3, and then this is x. These are real numbers. See, real numbers are everywhere, no? So real numbers greater than -3 means everything that's greater than -3, including -3, because there's an equal to sign here. So everything after -3 is included in this interval, but you just don't have 5 here. So it is starting from -3, goes till infinity, because it includes everything greater than -3, and then only excludes 5. Where you have 5, you exclude this thing from the interval, and then you have everything else here till infinity. That's why you get this thing, -3, comma, infinity, -5. Is it, what part are you not clear with?
Ma'am, when do we exactly use the closed interval?
Closed interval we use when we want to include the endpoint. So if you're doing this thing, that means A is included. If you're doing this thing, that means A is excluded from the interval. This means B is excluded. You don't include B, but you include A. And this means both are excluded. Both the endpoints are excluded from the set. Is it clear now?
Yes, ma'am.
Yes, ma'am. Yes.
Okay.
Uh,
We'll move on. Yes.
Ma'am, can you also explain the codomain and range, how to find?
How to find both codomain
Yes,
and
in this
range?
function. Yes, in this function.
Okay. See, codomain you don't find. You are given codomain. Range you find.
Okay.
So range is, your function is square root of x plus 3 by x minus 5. So you put a c here, you will get square root of x plus 3. See, this will involve quadratic equations that are not a part of this week. But I'll just give you a hint, because you will be doing quadratic equations later. C x minus 5. And if you square both sides, you will get x plus 3. Here you will get c square x minus 5 whole square. Now you open this thing,
Yes.
c square x square minus plus 25 c square. And if you take x on this side, you will get,
मैम लास्ट में x नहीं आएगा, 10 से स्क्वायर ही होगा.
yeah. Just 1 second. Then you x square plus have a
आएगा
x
आएगा. Yes.
5 c square minus 3, and then you'll have a negative sign minus 10 c square x equals 0. And then you have to find x such that this thing is, so what we're doing here is we're trying to find x such that fx is c, right? So we'll try to find x in terms of c. There's a, in later weeks you study quadratic formula. And quadratic formula is to solve quadratic equations. So this is a quadratic equation of the form ax square plus bx plus c. You will study all of this in later weeks, where this is of this form, right? So you can find x such that this thing is 0.
Okay.
That x such that it satisfies this equation. So you will find that x, and if that x is a real number for every c, that you will do it in later weeks. You have all of it there.
Okay,
So
ma'am.
if your x is always a real number, no matter what c you choose, then it's an onto function. Otherwise, it's not an onto function.
Okay.
On to the next question now. Give
So
this
now,
one a try. Give this question a try. Just 1 second. This one. Okay, I hope everyone is done trying this question. We'll do it here now. So a company opened recruitment for the post of data analyst, and there are 500 candidates. So the total number is 500. 500 is the total number of candidates. Then 285 candidates are proficient in Python programming. So let's just denote it by P. There are 285 candidates there. Then 195 candidates for C programming. And 115 candidates for Java programming. Then 45 candidates for Python and Java. 70 for C and Python, and 50 for C and Java. And there are 50 candidates that don't know any of the programming languages. So it's basically the universal set minus, or you can just say it will be easier if you observe it in the Venn diagram. So it looks like this. This is the part that they're talking about. If this is P, this is C, and this is J, then this part, these are the ones that are not proficient in any of the three languages. So the remaining part is that part, and this is 50. So what you do is and this total thing, this box thing, it's 500. So you have been given 500 people, and out of those 500, 50 are not proficient in any of the three languages. That means you're left with 450 people only. So this union, this thing now, this consists of 450 people. These three taken together consist of 450 people. And you have to find the number of candidates who are proficient in exactly one of the three programming languages. So you have to find this thing. This is what you have to find. So we'll start with the P1. This is P. And from P, you can just subtract. So to get the only P1, the ones that are just proficient, what you have to find is proficiency in just one language. That means proficiency in only Python, union with proficiency in C, and union with proficiency in only C, and proficiency in only Java. This is what is given. Is this part fine? This is what you have to find. Proficiency in only Python, which would be this thing. So I have this, no? You just have to find this one. So you'll have to subtract these parts. This you have to subtract, and this you have to subtract from here. Proficiency in only Python, only C, and only Java is what you have to find. The union of these three sets. So let's just come to only Python part first. So only Python is P minus, you subtract this intersection, right? This intersection is P intersection C. This intersection you subtract first, and then you subtract the other intersection, which is this, which is P intersection J. And because you've subtracted this 2 times now, this thing you've subtracted 2 times now. So you'll have to add it 1 time. Is this part clear? This is only P. If you'll do this, you'll get just this part. Is this part clear to everyone?
Yes, ma'am.
I'm a little bit confused in this thing.
See, what's happening is when you have P here, this is P intersection C, right? This entire thing is P intersection C, and this entire thing is P intersection J. Because you're subtracting P intersection C once, you have to find this one, the one that is this part you have to find.
Yes, ma'am.
So first you subtract this one, which is P intersection C. Then you subtract this one, P intersection J. But in this process, till this part, you've subtracted P intersection, this intersection, you've subtracted 2 times. Once when you subtracted this part, then the other time when you subtracted this part. So you subtracted this part, this part. This part you've subtracted subtracted 2 times. That's why we are adding it 1 time. Is it fine? Is this part
Yes,
clear to
ma'am.
everyone?
Yes, ma'am.
I
Yes.
will added this 1 time.
Yes, ma'am. Got it, ma'am.
Okay. So this is only P. Similarly, you find only J, which is P minus P intersection J and C intersection J. And then you add the intersection of all three. So you get only J. And in a similar manner, you do it for C. P minus P intersection C, J intersection C plus this thing. Now you know what P intersection C is. All the 2 at a time intersections are given to you. 2 at a time intersections, all of them are given to you. You have been given this one, and this one. All 3 are given to you. We don't have a problem with these ones, 2 at a time intersections. We have a problem with this because we don't know what this is. We know what these 3 things are, P, J, C. And we know the intersection of these taken 2 at a time. But we don't know P intersection C intersection J. So we first try to find this thing. And the question here is that you have to find the number of candidates who are proficient only in exactly in one language. Right? So the answer will be this thing. Let me just call this thing X, this thing Y, and this thing Z. So the answer is X plus Y plus Z, right? This is what you have to find. But to find this, you have the value of P, J, C. These intersections you have the value of, you don't have the value of this thing. Is there a doubt? So you have to find the intersection of the 3 sets. For this, you use the formula P union C union J equals P. It's actually cardinality. Cardinality of P plus cardinality of C, cardinality of J, and then you subtract the cardinality of intersections taken 2 at a time. And then this thing. Because we're familiar with we know the values of all the other terms. We have the values of all these, and this too. We just don't have the value of this one. That's what we want to find. So at P intersection C intersection J will be this union, this thing, and then just the sum of intersections taken 2 at a time. And the union of all of 3 has been given to us. So this is the union of all the 3 given to us. Why is this the union? Because we know that this entire thing, the universal set consists of 500 students. And out of them, 50 are not participating. Like 50 are not a part of any of these 3 sets. That means they're not proficient in any of the 3 languages. 50 are not proficient in any of the 3 languages. So this set, where a student is at least proficient in one of the languages, consists of 500 minus 40. So it's 450 students. So P union C union J is 450. Can you put the value here? P, C, and J are and then the intersections are 45, 70, and 50. This is 165. This is 400. How much is this coming out to be?
$595.
Is it how much is this total? Wait.
Great time.
615. Wait, have we made a mistake somewhere?
Ma'am, 20, the
It's
answer,
right.
it's the intersection point of the three. Like both, like the person who is proficient in all the three languages.
We haven't made any calculation mistakes so far, right? That's the only thing that I wanted to check.
No, ma'am.
So it's 20 only, right? I just wanted to be sure that there's no error in the calculations. So you get the intersection to be 20, and then you put it here. So you will calculate x, you'll have p which is 285. Can someone just dictate the values of these p intersection c and all of that so that it's quicker?
$70, ma'am. Then P into J, 45. Minus 20. So that
It
190
should be
maybe.
plus, right?
Yes.
What's 5?
195.
P intersection j is 45 and 50, right? P intersection c and c intersection j, 70 and 50. So
A union B union C is
190. 190, ma'am.
one is
40 and 95. So that's 330.
The sum should be then
320.
98,
325.
325
Yes.
be the answer then. Okay. I hope this question is clear to everyone. You
Yes,
just
ma'am.
have to identify this thing first. How
Yes,
you
ma'am, it is clear,
take
ma'am.
this. Okay.
But why we added 20 in the last? Means
We've
it
just used, if
in
you've understood this formula, that's what we've used. In the end, we've just substituted the values of these terms. Have you understood this formula?
yes.
We've only
Oh,
put the values then later. That's it.
yes, ma'am.
If there's any doubt in the formula itself, how we get here, then why are we doing this part? Why are we doing, these are the three things you're using. 1, 2, and 3. If there's a doubt in these three parts, then
No, ma'am.
otherwise it's just calculations. Okay, so coming to the
Please,
last. Yes,
ma'am, please explain third part.
which one? This one?
Yes, ma'am.
This is just the formula for intersection. So we discussed it in the last class where for 2 it is this. It's P, the cardinality of P, cardinality of C minus P intersection C. This is it. And for 3 it is this. First you take the sum of all 3 taken one at a time. Then you take the difference, then you subtract intersection taken 2 at a time. And then you add the intersection. It's like take intersection one at a time. This is one at a time. These are 2 at a time. And then there's 3 at a time. You can only go till 3. So you won't be given questions on 4. But even if you can extend this thing to 4 too, I guess. But you don't have it here. You don't have to deal with 4 sets at a time. You don't have to worry about that. There's just still 3 sets. So this is just the formula. You can try to check it using the Venn diagram if you want to.
Okay, ma'am.
Is there any way to find this by only using the Venn diagram?
Only using the Venn diagram. See, we've only used the Venn diagram for this one, right? This one we've only used the Venn diagram. This one we've only used the Venn diagram. This is like one of the most important formulas in set theory. This is for 2 sets too, and then there is for 3 sets too. So you need to derive this thing using the sets.
Okay.
You want me to do that here? It's not a part of your syllabus though.
No, ma'am. I can use formula.
There are some formulas, sometimes what happens is it's easier to use the Venn diagram. So like for these ones, you can't possibly remember each and every formula because this is not even a standard formula, by the way.
Ma'am, the P union C union T, it is a universe or just a combination of the all population. Look.
Okay, it's the whole population is given to be 500 something. So this set that you draw is the universal set. This is the universal set, and the union of all of 3 is just this. And they've mentioned it in the question itself that there are some students who are not proficient in any of the 3 languages. That means they lie here. They are here because they're not proficient in any of the languages, right?
No, ma'am,
So the
in a
union is
journal,
just
in a
yes.
journal, what actually P union C union Z? It's actually
It's this thing.
This thing. Okay. So it is not mandatory we always consider the union मतलब वो हमको कैलकुलेट करना पड़ेगा कि हमको क्या क्या दिया है. अगर हमें यूनिवर्स दिया होगा तो हम इसमें से मतलब माइनस करके निकालेंगे ऐसा कुछ मतलब
Yeah,
हमें
sometimes
क्वेश्चन
that's what I was saying. In the question, read here. It's given that 50 candidates don't know any of the programming languages. That means they're not a part of the set P, they're not a part of the set C, they're not a part of the set J. It means they lie here, outside the union of these three sets.
Okay.
Sometimes what happens is your P union C union J is equal to the universal set. Sometimes. When you know that every student is proficient in at least one language, when this is given, then you take P union C union J equals to the universal set.
Okay, ma'am. Yeah, that's all right. Ma'am,
Are there any other doubts from this part?
No, ma'am.
Okay.
ma'am, can I ask a doubt about graded assignment?
Yeah, we can do it after this question. You can't
Graded
ask
assignment.
questions from graded assignments, by the way. The deadline
Ma'am,
is to. You can't ask
ma'am,
questions from
if
the
we
graded
interpret-
assignment here. Not
if we
now.
interpret, if we change the data of this question, then
Which of this question?
no,
Yeah,
ma'am.
then the
Like
values will. Which
if we
question?
change the values of this, ma'am, interpreted the data of the question and then ask you, then you will reply or not?
No, you can't ask questions from graded assignments.
Okay, ma'am.
Not now, not in this class.
I think he mean a similar question to that given in the graded assignment.
If you just change the values, it's still the same, no? It remains the same.
Format of the question we will change. Just name and with the count.
I can only explain the question then. What is it asking? I'm not going to solve it here then. Okay, we'll solve this one then. So you have been given two relations and you have to find let's just check the reflexivity, the transitivity and symmetry of these relations, these two relations. The first one is X will be considered related to Y, or you also write it in this manner. Related to Y if X minus Y is divisible by 7, or you say 7 divides this thing. So if 7 divides X minus Y thing, then we say that X is related to Y. And the second one is if X plus Y is equals to 2, then we say that X is related to Y under the second function, the second relation. So let's just check for R1
Excuse me,
first.
ma'am.
Yes.
Ma'am, I've done this one.
Done this one.
Yes, ma'am.
Okay, that's well and good if you've done it on your own, but we are going to discuss. Has it been done in the class already? Is that what you're saying?
No, ma'am. I done this while you were explaining the previous question.
Ma'am,
Okay.
please carry on, ma'am. This is not done in the class.
Yeah, we're going to do it here. We're going to do this question here. So I've not given time for you people to try it. Do you want to try this question? Can we straight up just do it here? Okay, we'll just do this question here. So first is reflexivity. For this one, if you will take X minus X, then 7 divides X minus X, which is 0, which means X, every element is related to itself under this R1 relation. If there's any doubt in any of the part, you can just unmute yourself and ask. Else I'm assuming that it's clear.
Ma'am, please repeat.
Okay. Reflexive relation means that your x should be related to x, right? Or you can say, either way you can write it. This is the more used notation. Let's use this one only then. Xy should be in R1, right? Sorry, XX should be in R1 for reflexivity. So XX will be in R1. When is XY in R1? When 7 divides X minus Y. So XX is in R1 if 7 divides X minus X. X minus X is 0 and 7 does divide 0, right? Every number divides 0. That means XX is in R1. So your R1 is reflexive. And the second one is symmetry. So if you say that 7 divides X minus Y, so it just means that there is a B. In simple words, it means 7B is equals to X minus Y, right? Where B is some integer, not equal to 0. Or it could be 0. 0 works too. This is what it means when you say that 7 divides X minus Y, right? And now you want to check because you know that XY is a part of XY is in this relation. And what you want to check is if Yx is in the relation or not. So for Yx, you need a B1 such that 7B1 is equals to X minus Y minus X. So you can take B1 to be equal to minus B, right? If you will multiply this equation with a negative sign, you can take B1 is equals to minus B. And let's just not be, you don't even have to do all this. You know that if a number divides 5, let's just say a number divides 20, then it also divides minus 20, right?
Yes, ma'am.
So I was just, if you want to write it in proper manner, that's how you write it. Otherwise, you don't have to think about all of this. You can just simply, everyone just knows this, that if a number divides something, if A divides B, then in fact, A also divides minus B. We consider it to be dividing minus B as well. So that means if your XY is in the relation, YX is also in the relation. I hope this part is clear. That's why it's a symmetric relation too.
Ma'am, can you repeat that? The A divided by B, then B divided by.
Okay, if you say that A divides B, then A also divides minus B, right?
Yes, ma'am.
That's it. So if you have X minus Y minus X is just negative of X minus Y, right?
But it depends
you
upon
say-
values of X and Y, no, ma'am? X
It
minus
doesn't
Y.
depend on X, Y's value. If X minus Y, 7 divides X minus Y, then it doesn't depend on X, the value of X and Y. If 7 divides X minus Y, then it also divides the negative of X minus Y, right?
Yeah, negative of X minus Y, exactly. Minus of X minus Y. Yes. Yes, ma'am. Yes, ma'am.
That's
Y
it.
minus X.
I hope till this part it's clear. Then
Clear.
we have the third one, which is XY. Let's say XY is in R1. And then you have YZ in R1. So you have to check if XZ is in R1 or not. This is to check. This means 7. This is the symbol that we use for divide.
Yes, madam. Mod.
I
Okay.
don't want to write divide over and again. So I'll just use this thing. X minus Y. 7 divides X minus Y. This says 7 divides Y minus Z. Right?
Yes, ma'am.
So we know that if, let's just say there's a number that divides A divides B and A divides C as well. So A is going to divide the sum too, right? For example, let's just say 2 divides 4 and 2 divides 6 too. So 2 is going to divide 10, the sum of these, right? Or you can just look it as B plus C by A is the same as B by A plus C by A, because A divides
Right.
both of these, so it's going to divide the sum. That's it.
Yeah,
I
same.
hope this part is clear to everyone. So you can just add these two things. So we know that if 7 divides this thing, 7 divides this thing too. That means 7 is going to divide the sum too, right?
Yes.
So this is going to give you x minus z. This means 7 divides both of these. This thing, it divides minus z. And this is what you had to check. For this pair to be in R1, you need to check if 7 divides x minus z or not, right? So this means it's transitive too. Is R1 relation, so that means it's an equivalence relation, right? I hope this part R1 is clear to everyone.
Yes, sir.
Okay, next up for R2, you have xy is a pair in R2 if x plus y is 2. So let's just check for reflexivity. We want to check if xx is in R2 or not. So to check this, you would need this condition to be true, right? But this is not true for every x. The x you're taking from integers. And this thing is not true for, it depends on, okay, let's just do one thing. The relation defined is xy is a part of this, is in the relation. If I restrict it to just x, y belonging to the set 1, let's just say instead of this, I'm taking the relation to be this. Y is said to be in this relation. If x plus y is 2 and xy is from this one set, then do you think it's going to be a reflexive relation? We know it's not here. We'll discuss it in detail for someone who hasn't understood yet. But do you think this is a reflexive relation? This one. This one.
Yes. Yes, ma'am.
Why this is not a reflexive relation? For this pair to be in R2, you would need the sum of both x. So it's 2x, you need to be 2. Or x, you need to be 1. So this is only true when both the x's are 1, which is not the case because you're taking it to be from the set of integers. So it's not necessary that every element that you will take would be 1. But if you restrict your set to 1, then this is going to hold. Is this part clear to everyone?
Yes, ma'am.
Okay. It's
Ma'am,
not
I
a
have a doubt.
reflexive one.
Ma'am, I have a question.
Yes.
Ma'am, ma'am, can you write whole root of x square minus 64? X square minus 64 upon x plus 4. मैम जो डोमेन है इसका वो रियल नंबर से बिलोंग करता है, तो मैम एक सेट है गामा जो कि रियल जो इसमें नहीं आता है, इस फंक्शन में नहीं आता है, डोमेन के फंक्शन
Can we
में.
do this
तो
question after we are done with this one?
Okay.
We'll do it after
हाँ,
that. Okay. So R2 is not a reflexive relation. Then we have to check for symmetry. So let's just say that your x plus y is 2. Then your y plus x for this happens when this is true. And this happens when this is true. That means your yx is also in R2. Is it fine? It goes, this means goes both ways. This implies this and this implies this. Is it fine?
Yes.
Your xy is in R2, that means the sum is 2. So either you, whether you call it the sum of x and y or you call it the sum of y and x, it's the same thing. But it would have been different if you had minus here. So if the relation was this, then the things would change. Otherwise, now it's symmetric because you have plus here. I hope that is clear to everyone. And then the last part is for transitivity, where you say that x plus this is in R2, say, and let's take yz here. So both yz and xy are in R2, and you have to check if xz is in R2. And if this does not hold for any of the integers for which this thing is true, then this is not true, right? Then it's not transitive. So this means x plus y is 2 and y plus z is also 2. And you need to check if this is also true. So let's just take x to be 1, y to be 1 as well, and then take 0, 2. So this, take x to be 1, y to be 1, and let's just replace y from here. You will have y is equals to 2 minus x and y is equals to 2 minus z, right? And then you can equate these things. So you will get 2 minus x equals 2 minus z. So from here you will get 0 and x minus z. That means your x minus z, that means your x and z are same. So for this condition to be true, you would need 2x to be 2. So again, this condition is only true for x equals to 1, right? Let me just explain this part again. Here you need x plus, this is given to you. You need to verify this. So from here you get y is equals to 2 minus x, and from here you get y is equals to 2 minus z. So you can just equate these two things and you will get x minus z equals 0, which would mean x equals to z. And in this equation, for this equation to be true, you would need, so if x plus z is 2, that means 2x should be 2, right? From here. That means your x should be 1. And since your x could be anything in the integers, not just 1, that means this doesn't hold for every x and z, right? Is this part clear to everyone?
ये transitive नहीं है ना R2?
No, it's not transitive.
Okay.
If there's any doubt from this question, then I can explain that again.
Ma'am,
Yes.
ma'am, may you please repeat the transitive step for R1 once again?
Your relation was this, I guess. xy was considered, this x was considered to be related to y if 7 divides x minus y, right? Let's just say xy and yz are in this relation. And you have to check. So this is given to you. This is given. And this is what you have to check. You have to check if xz is a part of if x is related to z under the relation. So this implies it xy in R implies 7 divides x minus y and 7 divides y minus z, right?
Yes,
And
ma'am.
here you have to check 7 divides x if 7 divides x minus z. So you have to check if these two conditions are true, then is this true as well? That's what you have to check, right? This is the given condition set, and this is the condition that you have to check. So if 7 divides x minus y, what we were doing here is, let's forget these things for now. Let's consider any two numbers x and y. And let's say 7 divides capital X and 7 divides capital Y. Then our claim was that 7 divides the sum of these two too. How? We can prove this, but I don't want you to go into the proofs because that's not needed. I just want you to observe this thing, that if a number divides x, it could be any number, but we've taken 7 here. If 7 divides x and 7 divides y, this means when you divide x by 7, the remainder is 0, right? And when you divide y by 7, the remainder is 0. So you get a number here, right? That means x plus y is also divisible by 7, isn't it? Or it's like this thing. 7 divides x means there is a b such that 7b is equals to x. 7 divides y means there is a c such that 7c is equals to y. And if you'll combine these two things, where b and c are integers, if you'll add these two equations, you will get 7b plus c is equals to x plus y. And if b and c are integers, that means b plus c is also an integer, right? Now this means that you have an integer which when multiplied with 7 gives you x plus y. That means 7 divides x plus y, right? This is the explicit proof of what I've said. That if 7 divides x, 7 divides y, that means 7 divides the sum too. And the converse is also true, by the way.
Yes.
No, it's actually, you'll need more conditions to it. The converse is not true. This is not always true. Is this part fine?
Yes, ma'am. And ma'am, if the domains are given, if the integers are in the domain, will it be symmetrical or not?
Are you talking about this particular relation 7, the 7 divides 1? Are you talking about this relation?
Yes, ma'am. This one particularly.
It is already symmetric. We've discussed this. This relation is symmetric.
Okay, ma'am.
If you'll restrict the domain in the sense, if you'll restrict where you're taking your x from. Currently, you're taking it from z, so it's symmetric, right? If you will take it from a subset of z, then it's still reflexive or symmetric or everything. But if you'll extend it, it might change. Okay?
Okay, ma'am. Thank you, ma'am.
Any other doubt till this part or from practice assignments or anywhere?
Yes, ma'am. I have a doubt.
And not the graded one, please. No
Yes,
graded
ma'am.
assignment questions here. Okay.
Ma'am, I have a question. I told you, ma'am. In a Mint hackathon, there are 6 curly hair students and 7 straight hair students participate. Ma'am, please note
What?
down this data.
Yeah.
Ma'am, in Mint hackathon, there are 6 curly hair students and 7 straight hair students participate.
Okay.
Out of these students, 5 are males and 10 either straight hairs or males.
And what?
10 either straight hair, सीधे बाल, or are males.
Okay.
Find the number of females with curly hair. जिनकी छल्ले बार हो, ठीक है. This is my question. Question mark.
You have we have 4 sets: C, S, F, and M. And okay. So your 6 plus 7 is going to be the total number of students. So you have total number of students as 14. That's the total. Then out of them, you don't even need this thing because it's either the student has curly hair or they have straight hair, so the total will give you 14. The total number of students will be 14, and then 5 out of those are males. So the remaining ones are females. So females are 9.
Total female.
And then you have F intersection C. So females with curly hairs and females with, okay. The total number of females are females with curly hair, union females with the straight hairs. And straight hair and male.
मैम जो स्ट्रेट हेयर विथ यूनियन मेल, मैम इसमें वो माइनस कर देंगे ना.
14 minus 10 is 4. And this should be the same as S intersection, no, M intersection C, let's take. Males with curly hairs is 4.
ये same type question graded assignment में है मैम.
Okay, I already mentioned that you're not supposed to ask graded assignment questions here.
Same type of question है graded assignment.
The question is same like Bengal.
Same है मैम, same ही है, खाली state change किया और वो ये change कर दिया बस खाली.
Okay, please don't ask questions from graded assignment before the deadline. Then it's almost done. The questions, by the way, almost done.
Ma'am, can I interpret the data actually the value?
What?
मैम जैसे एक क्वेश्चन और है तो उसमें मैम अगर डाटा चेंज कर दिया तो मैम कॉन्सेप्ट
I already told you that you can't change the data. It doesn't change anything. The concept remains the same. You're not supposed to ask questions from graded assignment by changing the data.
Okay.
I already explicitly mentioned it. Okay. Are there any other doubts?
No, I have not.
Anyone else?
Hello, ma'am. I want to know that the type of questions asked in qualifier, will there be any difference from graded assignments? Take out of graded assignments question.
So they would obviously not be the same as the graded assignment questions, but if you have been able to do the graded assignment questions and everything, then you will be able to do it in the exam. They won't exactly be the same, but the concepts would remain same.
Will there be any questions like out of the graded assignments?
No, you won't be given the direct questions from graded assignments and from anywhere on the portal. You won't be given direct questions from there.
Okay.
But those are sufficient.
Not
for
from
practice.
PYQ also.
The questions generally you won't see the exact questions there, obviously. They would change. So if you have been able to do questions from PYQs and everywhere, you don't have to worry at all about the questions in your exam, in qualifiers or anywhere, even in the end term, because the questions would be more or less the same. Doesn't mean the concepts won't be shuffled here and there. The question would be from what you've done.
I've seen the PYQs, but the afternoon session is quite different from the PYQ from the noon session, forenoon session.
What? What were you asking?
Ma'am,
मैम आई हैव अ डाउट कि अगर कोई फंक्शन दिया हुआ है और वो रूट में है, उसमें डिनोमिनेटर भी दिया हुआ है, तो मैम अगर कोई फंक्शन दिया हुआ है और उसका डोमेन रियल नंबर बताया गया है, तो मैम इसमें क्या चीज जो है इसकी कार्ड मैम क्या चीज डोमेन नहीं होगा, कैसे एक्सक्लूड करें डोमेन को कि ये चीज डोमेन नहीं हो सकती?
The square root, if it's square root of x, the negatives would not be there in the domain.
No,
That's it.
सपोज रूट मान लिया एक्स स्क्वायर प्लस वाई दिया हुआ है, एक्स स्क्वायर माइनस वाई दिया अपन समथिंग मान लिया
You won't be
एक्स
given
प्लस
x square minus y. You won't be given two variables. You'll only deal with one variable.
मैम तो हमें मेरा ये क्वेश्चन था कि जो रूट के अंदर मान लिया हमारा सी आया और डिनोमिनेटर में जब हम सॉल्व किए इक्वेशन, वो जो नीचे वाले डिनोमिनेटर को बराबर 0 किए तो कुछ और आई, तो इन दोनों के बीच में हम किसको ज्यादा लें किसको कम लें, मतलब हायर पावर किसको लें, मतलब रेंज में कहाँ से स्टार्ट होके कहाँ पे
You have
खत्म
to
होगा
take
ये
the
नहीं पता।
intersection. If you're talking about the domain, if you have something in the square root in numerator and then there's something in the denominator which you're worried that it would turn out to be 0, so you just you have to take the
No, मैं
smaller of
suppose
one of the two. That
suppose
means
मैं
the
एक्स
intersection
स्क्वायर,
of the two.
ओके
The
वेट मैम
intersection of the
सपोज
two you have to take.
मैम लिसन प्लीज। मैम सपोज एक्स स्क्वायर माइनस सी अपॉन एक्स प्लस वाई ऐसा कुछ दिया हुआ है, तो मैम एक्स प्लस वाई को 0 रख के वाई की वैल्यू एक्स की वैल्यू निकाल लेंगे, उसके बाद एक्स स्क्वायर माइनस सी इज इक्वल टू 0 रख के सी की वैल्यू निकाल लेंगे, तो इनके बीच रेंज क्या मतलब कैसे डिफाइन करेंगे?
What's y here? You won't. That's what I'm saying. You won't be given y. The function would only be given in one variable. What's y here? What's your function?
The function is written in the root and denominator. तो मैम एक्स सी और वाई में रिलेशन तो होगा ना कुछ, तो वो रिलेशन आप पूछ रही हैं?
What's your question?
मैम एक्स स्क्वायर माइनस सी रूट ऑफ एक्स स्क्वायर माइनस सी का पावर 1/2
Okay.
to the whole power 1/2. Okay.
What do you have to do here? What do you want to do?
मैम इसमें इसको मैम एक्स स्क्वायर माइनस सी इक्वल टू 0 करेंगे, सी की वैल्यू आ जाएगी एक्स प्लस वाई करके
What are
0
you
करेंगे।
asked here? What's the question here?
मैम इसमें लिखा है कि अगर डोमेन रेंज को बिलोंग करता है तो एक सेट let a set be the
Is
set
it
of
from
integer which are
graded
not in the
assignment?
domain
Make
of.
sure it's not from graded assignment.
Yes, ma'am.
But I want to just ask, ma'am,
Don't
okay,
ask anything from graded
leave it.
assignment.
Okay.
Do it the way you want to do.
Ma'am,
Okay.
ma'am,
Yes.
ma'am, what about the minimum and maximum value regarding the domain?
Are you asked I don't think you've been asked the minimum value or maximum value in the domain. I think you're talking about the range.
Yes, ma'am, range.
We've done questions on range, no? The maximum one and the minimum one. We did one question in the last class.
Ma'am, is there any way to get the PYQ of qualifier?
PYQs, I think you can ask the TAs and they'll share those with you.
Where, ma'am?
Just ask the TAs when you have a TA session, a session with the TAs. Just ask them, and they'll provide you the PYQs if you have to be provided with them.
Okay. Ma'am, will there be class tomorrow?
No, I don't think so.
But in the calendar it is showing classes from 6 to 8 p.m. Mathematics.
It must be of some other subject. It's you don't have a class for Math 1. Okay, we'll just
मैम
yes.
एक डाउट था मैम। मैम किस कोई भी फंक्शन दिया हुआ रहता है तो उसका कोडोमेन दिया हुआ ही रहता है या फिर हमें फाइंड कर सकते हैं कोडोमेन को?
Codomain's just a set which contains range. That's it. That's what you have to make sure. You won't be asked to find codomain. You'll only be asked to find the range.
ओके, कोडोमेन फाइंड करने के लिए नहीं बोलते
Codomain,
ना,
no one asks.
ओनली डोमेन या रेंज, दोनों में से
Yes.
दोनों, या तो दोनों बोल सकते हैं या दोनों में से, राइट? ओके।
End the session here, guys.
Ma'am, range
Thanks.
are the possible outcomes which can be performed on the function,
Yeah,
right?
the possible outcome of the function. That's range.
The feasible function, the physical thing.
Okay, so if there's more doubts to this week, then we'll take up them some other time. We're ending the session here.
Okay, ma'am.
Everyone,
Thank you, ma'am.
thank you for joining. Thank you so much, ma'am.
Thank you, ma'am.
Thank you, ma'am.